Section 5.2, double integrals over general regions. So in the last section, section 5.1, we talked about double integrals over rectangular regions. So those were perfect rectangles. Basically, our double integrals had constants on the lower and upper bound of each integral. In this section, the bounds on our integral might not be constants, they could be functions. And because of that, there are two separate types of regions that we're going to classify as a type 1 and a type 2 region. To me, type 1 and type 2 is a little bit vague, and so it's hard to call them type 1 and type 2 because they don't really relate well to me. Instead, I like to call them vertical or horizontal regions. And I'll show you exactly what I mean. A type 1 region, rather than having a perfect rectangle like we had in section 5.1, a type 1 region is almost like a rectangle except for a function is going to carve out the top and the bottom of our region. So the left and right sides are still basically parts from a rectangle, but the top and bottom could be some functions. And the top function, we're going to call that something like y equals g1 of x. So it's some function of x for the top. And then the bottom function, that's also a function of x. So we'll call that g2 of x. So we have a top function and a bottom function. And in order to think about the area in this region, I'm going to have you visualize it as a bunch of vertical lines that are connecting the top and bottom functions. And we're going to start drawing these vertical lines from the very left edge of our region until we can make our way all the way across. And you can see that every one of the vertical lines I've drawn is hitting the top of our region, that g1 function, and every bottom of those vertical lines is hitting the bottom function, the g2 function. And so this is why I like to call this region vertical, because you can draw vertical lines that are connecting the functions that carve out the top and bottom. On the other hand, we could have horizontal regions. So again, let's imagine that we started off with some perfect rectangle like we had in section 5.1, but instead of keeping it that way, we're going to allow a function to carve out the left and right hand sides of our region. So this time the top and the bottom of our region is still made up from that perfect rectangle, but the left side of our region is a function. And this time it's not a function of x, because we know that functions of x cannot, well, this one would fail a vertical line test. So we would have to rewrite this as an x equals some function of y. And so instead of calling it like a y equals f of x or something, or x equals g, we're going to denote this with an h. So our leftmost function, we'll call that h1. That's our left side. And our rightmost function, we'll call that h2. Oops, and I'm writing that as a function of x. That's a bad habit. Well, it's a normal habit, but this is a function of y, not a function of x. And just like our type 1 region, I'm going to draw a bunch of lines that are horizontal this time rather than vertical, and I'm going to start from my bottom and work my way up. Every one of these horizontal lines that I'm drawing is connected by the h1 and h2 functions. So, the general regions that we're going to talk about in this section can be categorized as either type 1 or type 2. Once you can identify which one you're going to use, you can set up a description of your region using basically bounds between the x's and the y's. So in our type 1 region, where we drew vertical strips, the y values, we're stuck between two functions of x. The smaller value of y is going to be the bottom x function, so that would be the g2 function, g2 of x. And then the larger values of y, those are the ones that are on top, those are constricted by the g1 of x function, the top function. And we were spanning over the x values from the rectangle's left side to the rectangle's right side. So x went from A to B, some constants. For the type 2 general region, this time the y values were between constants because the y values came from the rectangle. So I'm going to let y go from C to D, for example, and then the x values are squeezed between functions of y. So the smallest x values are on the left, that's our h1 function, and the largest values of x were on the right, that would be like our h2 function. Now something that's really easy to mix up here is the fact that in type 1 regions, the y bounds are functions of x. So it could look something like the smallest value of y is x squared. And so that's easy to feel confused about because we're setting the lower limit of y by using values of x. We'll do some examples that'll help clarify that. But then the same thing happens in the type 2 region. X is squeezed between two functions of y. So maybe like the largest value of x, in this case, would be like sine of y. So again, it feels strange because we're saying a value of x is y. And we'll get through some examples here to make more sense of that in just a second.